Over the years, I've been interested in the problem of designing and building computer systems which increase the productivity of programmers, as well as being more fun to use than conventional systems, by focusing on providing the users with various forms of explicit and implicit assistance. The user, programmer, is thus free to concentrate more fully on the creative aspects of the problem he's working on. Essentially what we're trying to do is to create a partnership between the computer and the user, in which the computer gradually takes on more and more of the routine aspects of programming as we come to understand and identify them. The system I'm going to show you today is an extension and continuation of that interest. It is built in InterLISP, a version of the LISP programming language. InterLISP itself is an example of a helpful system. It contains a number of facilities designed for aiding the user. For example, there's the automatic error correction facility called DWIM, which is short for Do What I Mean. DWIM is automatically invoked when an error is about to occur and attempts to correct the error using global as well as contextual information. Another example is the programmer's assistant, which is an intermediary agent that sits between the user and the programming language LISP and captures and records all of the user's interactions with the system. The user can direct specific commands to the programmer's assistant to repeat or even to undo various operations that he's performed. We will probably have occasion to see these facilities used in the demonstration you're about to see. However, the principal innovation in the system I'm going to show you is the way that it uses the display to allow the user to more effectively manage his environment and to switch back and forth easily between various contexts and tasks, such as defining his programs, editing them, debugging them, testing them, and so on. The demonstration will be in two parts. In the first part, I will perform a little toy programming exercise just to introduce the various facilities of the system. In the second part, I will show you how an experienced user might use the system to get real work done. In the upper left-hand portion of the screen is my TypeScript window. The blinking caret indicates where the next character that I type to the system will appear. The circular crosshair shape is the cursor, which indicates where the current position of the mouse is. I move the cursor by moving the mouse. I use the cursor to point at different parts of the screen to direct the system's attention to it, and during this demonstration I will also use the cursor as a way of pointing at a particular place on the screen that I would like to direct the viewer's attention to, as I just did with the caret. Now I'm going to define a definition for the LISP function factorial. I type in define q factorial of n. Notice the caret moves along. If n is greater than 0, then n times factorial of n minus 1. The cursor changed to an hourglass to indicate that the system was computing, and now it's back at the crosshair shape. And I've gotten this error message, incorrect defining form fact. Now, since I'm pretending to be a naive user, I don't understand what's going on, and I type question mark, which is a command to the programmer's assistant for more information. In this case, the programmer's assistant looks back at the previous event, notices what the particular error was, and using information that it has about define q, namely that it requires lists as its arguments, generates this particular explanation. Basically what happened was I left off a left parentheses in front of the first argument to define q. Now, instead of having to retype the whole expression, since the programmer's assistant has been capturing and recording all of my interactions with the system, I can simply edit this expression up here and insert the missing left parentheses. So I move the cursor to this point over the left parentheses and select this left parentheses by pressing one of the buttons on the mouse. The system indicates that this has been selected by inverting it. The parentheses now appears white on black. And now I'm going to perform an editing operation, so I need my edit menu. I come over here to my menu, select the edit command, and in the prompt window, the system says use the left button on the mouse to indicate where I want the center of the menu to appear. And the cursor has changed to an icon which is suggestive of bringing up a menu. Now I'm going to make my edit menu come up right over here. Notice when it first came up, it partially overlapped the menu and automatically adjusted itself so that both were now visible. And now I select the insert operation. Now in my TypeScript window, the caret is now immediately in front of the left parentheses, which I'd previously selected. Now what I want to do is insert a parenthesis, so I type parentheses, and that's all. And we see that the parentheses has now appeared at this point, and the caret is back at the end of the TypeScript. Now what I want to do is cause the system to effectively read what I should have typed in the first place. And I do this by selecting the D, and using a different button on the mouse, I extend my selection through this right square bracket. And now I'm going to use an operation on the window menu, which says to read that selection. So first I have to bring up the window menu, and we do this in the same way as we brought up the edit menu. Now the command that I think I want is called read selections. And since I'm not sure, when I make the selection, I hold the mouse key down instead of clicking it, and the system tells me what it would do rather than just doing it. In this case, the prompt window now says causes selected material to be treated as input, which is exactly what I want to have happen. So I release the mouse key, and you'll see in the TypeScript window, the characters that were selected now appear as though they had been typed. And in fact, this time, the definition goes through, and I now have defined my function factorial. So now let's try it. We will type factorial of 3. Now you might have noticed that there were a few spelling errors in the original definition. Now what's going to happen is they'll cause errors, and dwim, which I mentioned earlier, will be invoked, and it will try to fix them up. Let's see how it does. Well, the first thing a dwim types is greater goes to greater, and I type yes. And now it types fact goes to fact. And greater was built in. The reason why dwim knew about fact was that the programmer's assistant noticed it when I first defined it. And since FACCT is pretty close to FACT, that was the correction it offered. And in this case, I didn't type yes or no, and after a specified period of time, the system supplied a default answer, which in this case was yes. And then ran into an error, which was one that dwim could not handle. It says non-numeric arg nil in I times, and I am now in a break. Basically, I can type anything at this point that I could at the top level. I could call other functions, perform other operations, but in addition, I can examine the state of my computation, edit functions, fix the problem, and even continue the computation. So I effectively haven't lost anything. The system indicates that I'm in a break by using the prompt character colon, whereas you notice up here, left arrow was used for the prompt character. When I went into the break, this break menu, which is a menu of commands that are useful when breaks, automatically appeared so as to make it easy for me to perform these operations. In this case, I want to ask the system for a backtrace to show me the computations that were performed in order to get to this particular error. I do this by selecting the BTV command, which is backtrace with variables, and the backtrace window will automatically appear at the right of the screen, and we see my backtrace. So what happened was factorial was called with n equal to 3, and then it was called with n equal to 2, and then with n equal to 1, and now I'm in a break. So it looks like all of this proceeded properly, and I still don't understand what caused this non-numeric arg nil error. So I will try the question mark command. In this case, the programmer's assistant finds the error, and using information about times, namely that each of its arguments must be a number, which I knew, it tells me that in the expression n times factorial of n minus 1, which appeared in the definition of fact, the value of factorial of n minus 1 is nil when n equals to 1. So basically what happened was when factorial was called with n equal to 0, it returned nil because I forgot to say what to do when n was equal to 0. So now that I know what the problem is, I simply have to edit my definition for factorial. So while still in the break, I tell the programmer's assistant to pretty print factorial, and my work area window automatically appears, and here is the definition of factorial. Notice that greater is now correctly spelled, as is factorial, because these corrections were made before the error. And what I want to insert is a clause which handles the n equals 0 case. So I select the right square bracket, and I select the insert on the Edit menu, exactly as I did before. And the Edit menu now automatically moves so as to be closer to the place where I'm editing. We see that the caret is now in the work area window itself. And I type right parentheses, else 1. Basically what I said is that if n is not greater than 0, then factorial should return 1. The edit has been made. I could perform other editing operations at this point, or in fact do anything else while on the break, but since I'm happy with this definition, what I want to do is tell the editor that I'm finished. So I select the Done command in the Edit menu, and in the prompt window appears the message, fact changed, which means that the edited definition has now replaced the old definition. So let's try it out. We'll say factorial of 2, and it returns 2. Now, we've fixed factorial, and at this point we could simply go on and do something else, but we're still in this break. In other words, times is still waiting for some number to multiply 1 with to return as a value factorial of 1, which is then multiplied with 2 to return as a value of n equal to 2, etc. So what I'm going to do is tell times what that number should be and cause the computation to continue by simply using the return break command. And up in the prompt window it says input expression, and I type 1. And what we see happen is that 1 is returned as the value of my break, and this 6 here is the original value of factorial of 3, which we started at the upper part of the TypeScript window. Now, we'll try factorial in a few other examples to make sure that it's running correctly. And rather than type in these examples, we will use the Programmer's Assistant history facility in order to simply supply new values for the argument to factorial. So I bring up the history menu by using the menu and select the use command. And in the prompt window it says select the targets, input the objects to be substituted. So I select 3, and we'll use 4 for 3, 5 for 3, and let's try factorial of 10. And in the TypeScript window it says use 4, 5, 10 for 3, and 4. 4 was the event number in factorial of 3. This is event number 10. And here are the 3 values for factorial, 24, 120, and 3 million some odd. Now let's look at a complete replay of our history. We'll use the Programmer's Assistant command for replaying the history. History window comes up, and we see in reverse order the history of our session. Here's the most recent event. Use 4, 5, 10 for 3 and 4, factorial 4, 5, 10, etc. Return 1. Factorial 2, that's when we tested factorial in the break. Pretty print. BTV. These little boxes here are the bells. That's the way the system prints bells. And I'm not quite sure why they're there. And I'll type a carriage return and get the rest of my history. Factorial of 3. This is event number 4 here, the one that we did the use command on. And back through our original definition. So, what we've just seen was I defined a function, I used the Programmer's Assistant to explain what went wrong with the definition, ran the function, DWIM corrected a couple of errors, I went into a break, got a backtrace, edited the function, continued with the computation, and finally used the Programmer's Assistant to test the function out on a few more values. Now I'm going to switch hats and show you how an experienced user might use the system to get real work done. The first thing I'm going to do is send a message to a colleague to ask him why those bells appeared in my history window. So I select the operations menu, bring that up, and select the send message command, and my send message window will appear. And I'm going to send a message to Macinter, no copies, subject is bells. Now I'll send the message. I had misspelled his name, and Dwim corrected it. It now says Miss Sinter, and up in my prompt window, it says Miss Sinter, OK. Now, the next time he reads his mail, he should get a message. And in fact, he's, as I understand it, told the programmer's assistant to keep watch on his mail file, so it will tell him when mail is arriving. And I should get a response back from him shortly. Oh, I have mail coming in. This is a message from a user of InterLISP in Los Angeles, and he has a question about the system. And while we're waiting for Larry to respond, I might as well answer this message. So I will again select my send message command. The prompt window says, the selected recipients are not recognized, message not sent, you may edit the message. And we come back here to the send message window and see that what happened was I was typing too fast and I put the subject of the message in the copies field and actually began the message in the subject field. Rather than having to retype the entire message, I can simply edit this and send it off the way I want to. So what I'll do is get my edit menu back up, and I'm going to move subs to before Neil using the move command. And then I will move Neil down into the body of the message. And why don't we fix it up with a comma and carriage return. Now I'm happy with the way the message looks, and I simply hit the done command on the edit menu, which in the case of a message causes it to be sent out. Remember, when we edited our function factorial, it caused it to be redefined. And up here in the prompt window it says Goldman at ISIB OK. This is probably my message reply coming back from Larry. Now, the entire message isn't visible because it overflows the bottom of the window. What I'm going to do is scroll the window up, or actually, if you think of it, scroll the contents of the window up. If you sort of think of this as a window on a larger document, and I can slide this opening up and down over that paper, what I'm going to do is grab this paper at this particular place and pull this up to the top of the window. So now I can read the entire message conveniently. Now what Larry's told me is that the reason that those bells were printed was that 10x has a feature in it that if it ever gets a full screen load without anything being typed, that it assumes the user hasn't had a chance to read the screen, and it waits for him to type something before going on. And as Larry points out, what I should probably do in this case is disable that facility because I'm handling Windows in my own special way. So I'm going to send Larry a message back. It turns out that he wrote me a similar function some time ago, which I used for setting the page width. And what I'm going to ask him is whether or not I can simply combine this new facility and that old function. Now, at this point, what I'd like to do is simply include the definition of the function in my message. And there's a real easy way for me to do that. First, I'm going to come up here in my operations menu and select the pretty print command. Now, I'm still in the middle of sending this message. This is just going to start a separate process, which is going to go on in parallel. And in the prompt window, it says input name of functions. My function name is called set page width. Now, in the lower right-hand corner, my work area window comes back up. There's our old friend factorial, and the definition of set page width will be pretty printed. Actually, it wasn't in my system, and the file package automatically went and obtained it from the file that contained the definition. Now, I will select the definition, and I'm going to use the read from selections operation on the window menu to cause the characters to be typed into my send message window. I hit read from selections, the send message window comes back up on top, and my definition is inserted. At the same time, in this message, I'm going to ask Larry about why the mail checker told me I had mail from system when, in fact, I think it should have told me the mail was from Macinter. And now we'll just send this message off. And up in the prompt window it says Macinter OK. This sort of casual back and forth communication is an important part of the way that we use computers today. For example, 20 or so of my colleagues are using the same time-sharing system as I am, and we exchange messages frequently. I also get a number of messages from users at other sites on the ARPA network. So it's really important to me to be able to switch context from, for example, editing a program or being in a break to receiving a message and sending one back if I wish, without much overhead. In this particular example, what was important was how I was able to grab a piece of my programming environment and insert it directly into the message. And we will see when I get the next message back from Larry that it will probably contain a function definition in it that I can simply point to and install in my programming environment. This is probably the reply from Larry now. Now I see here he has included a definition for the function setPage. What I'm going to do is select that definition, and then use the read from selections command, and the definition will appear in my TypeScript window. Now you remember why we did this was that we were seeing those bells in the history window. So let's use setPage to set the page width and height both. Let's say 72, 100, and then I'm going to ask for my history again, and we'll see what happens. So let's watch the history window. And there we see a complete history of what we've done without any breaks. So we fixed that problem. Now, let's bring the message window back on top and see what Larry has to say about the problem with the mail checker. The rest of Larry's message explains that the mail checker routine simply looks to see who last wrote on my mail file and that the only guaranteed way to find out the real name of the sender is to look in the mail file itself at the message. And he tells me that he has a function which can find the position of the last message in my message file, and from there I can simply read the name of the sender. So what I'm going to try to do is make a change to this check mail package to have it actually look in the mail file and tell me the real name of the sender of the message. So the first thing I want to do is load in Larry's file. So I type to the TypeScript window, load, and I can simply select the name of the file from the message and use read from selections to insert it into my TypeScript. And this will go and obtain the file from Larry's directory. Now my next question is where to make the change. Now I didn't write the check mail package, but there must be some function in there which simply prints a message saying where I have mail from. So I'm going to call MasterScope, which is a package in LISP which analyzes large programs, and have it analyze the program check mail and see if I can't spot what looks to be the name of the function that I want to change. So I will select MasterScope, and MasterScope window comes up, and I will say, who is called by checkmail? Now MasterScope will go and get the definition of checkmail from the file and analyze it, and will give me a list of all the functions that checkmail calls. And here's a list of the functions that is called by checkmail. And this function informmail here looks fairly promising. So I will pretty print informmail. I don't have to type the name, I'll just use read from selections. And in the work area comes a definition of informmail, and this is in fact the function that I was looking for. You see, it prints the string mail from, and then it prints the name of the sender, and it prints the date. So what I want to do is to insert in this definition instead to position myself in the mail file correctly, look for the from string, and then read the name of the sender. So I'll use my edit menu to perform that insert. I want to search the file. Actually, I don't remember how that function works, so what I'm going to do is consult the online InterLISP manual by using the helpsys package and have it tell me what the names of the arguments to this function are so that I can get them right. So I select the helpsys command. I'm still in the middle of my edit, but the helpsys window comes up, and I can say, tell me about file search. This switching back and forth is really a very important part of the system. Oh, that isn't even the name of the function. So let me try, tell me about searching files. Because it means that I don't have to break my context. I can keep track of what it is I'm trying to do at all times. Now, the function I want is file pause. It takes the name of a string, the name of the file, a start address, etc. I'll say goodbye to helpsys. And now I'm back editing. And I backspace away my file search. File pause. I want to look for from. Actually, why don't, for accuracy's sake, I will simply insert the string as it appears in the message that I want to look for. So I will bring my mail window up on top, scroll it back to the beginning of a message, select this string, which is what I want to look for in the mail file, and use read from selections to insert that into my edit. The work area window comes back up on top. And now we know for sure this is the right string because we actually got it from a message. Now, I want to search. Let me get my message window out of the way here so I can read what was on my help sys. I want to search in the file, mail file, and starting from the location get mail pause, that's Larry's program. Okay, now I'm positioned in the mail file as of the name of the sender, and I simply say sender gets read mail file. And now let's check out Inform Mail. We'll tell the edit menu done. And in the prompt window it says Inform Mail changed. Now remember the last time we got mail, it said mail from system. So let's just call Inform Mail and see what it says now. Mail from Macinter. So we have fixed that particular non-feature of the check mail routine. Mail from Burton, yes. This is a message from a user at BBN. Actually, I would like to have my Inform Mail tell me that it's Burton at BBN, the whole thing. And the reason why it just said mail from Burton is that, remember when we made the change, we just told Inform Mail that after the from, it should just do a read, which reads the next word on the line. So we should have it read the whole line and print that. So before processing this message from Mr. Burton, why don't we go back and make that fix to Inform Mail. Now this basically just involves replacing the call to read with a call to the LISP function rstring. Now I hit done. And type Inform Mail T and see what happens. Much better. In fact, while we're at it, why don't we fix Inform Mail to tell us what the subject is too? So we'll simply edit it again. What I want to do is right here, before it prints that last square bracket, I want to insert an expression very much like what we've got up here. I want to say, if you look in the file and you find the string subject, which I will grab from the message file itself, so I know it's exactly what appears there. Read from selections. And what you should do is start a new line, print the subject, read from selections again, and do a R string, just like we have. In fact, why don't we just select the R string up here and insert that again into the edit. Again, using read from selections. And that's all there is to it. So what this says is, if the string subject appears in the file, then print subject and print what follows it. So I'll hit the done button. Inform Mail changed. And let's just redo that. We can do that by selecting it and using the history menu. Redo. Very good. Okay, now let's see what Mr. Burton has to say. He says he has a problem with a file that just won't load into LISP. It seems to stop and wait. So the first thing that I'm going to do is make a copy of that file and try it and see what happens. So I will simply select what he's included in his message. And then I will bring up the document menu, which will let me write out a file. I say write file, and in the prompt window it says the selected material will be written on a new version of the file, and I should input the name of the file. Let's call it burton.bug, new version. And the file is written. So now we'll try to load the file. No, I don't want to see any mail right now. We're in the middle of something. Load burton.bug. Well, loads okay for me. Let's undo this because he made some changes to the system in this file. We'll select this event, come over to the history menu, and select undo. And now we want to send Burton a message asking for more information. And in the prompt window it says, should Burton at BBN OK. Now let's see what the message from card was about. We'll select the read mail command on the operations menu. The message is actually in my mail file, it just, we didn't read it at the time that it came in because we were working on Burton's problem. I'll scroll this up to the top. The message from card is a question about the LISP manual, which I will answer. But, you know, I might have forgotten about this message because it came in the middle of something. I think what I'd like to do is fix my mail checker so that when I say no to a message, as I did up here, it will change the message window itself, change the caption to say that I have mail waiting from a particular person. So in order to do this, we'll first get master scope back to find out who checkmail calls. There's a function called askUser, which most people use for, yeah, there it is, askUser, for handling those interactions of, you know, questions involving yes and no's. And I'll simply advise askUser. So what I want to do is say advise askUser after, if its value is equal to no, then to call this function setWindowSpecs, which changes a window, and to change it to say the caption second string is the sender. And why don't we change the background too, to be vertical stripes or something like that. Actually, what I've just done is advised all the calls in the system to askUser, and we don't want to do that, so let's undo that, and then we'll re-execute it, just advising the call to askUser in checkmail. Now we say use what I want to do is use askUser in checkmail instead of askUser. And now we see that it's going to advise askUser in checkmail. The hourglass indicates that the load average on the system is starting to get more heavy, which is why our response is slower. Now let's test this out by sending myself a little message and saying no. Okay, send that out. Teitelman, okay, and we should be getting the message in shortly. Mail from Teitelman, no, I don't want to see it. And let's see what happens to the message window. So, to summarize, what we've seen here today is a system that uses the display to provide the programmer with various forms of assistance. In particular, the technique of multiple windows permits the programmer to effectively manage several different tasks in context and to switch back and forth between them naturally and easily. I think the use of the display in this fashion is an important area for further exploration and one which will yield great returns in terms of programmer productivity.